Hello everyone, welcome back to Advanced Survey Recordings. Today we are here to discuss about Module 3, which is curve surveying. Going to the take, we have curves, necessity and types, simple curves, elements, designation of curves, setting out of simple curves, compound curves, reverse curve between two parallel straights and transition curves. Now let us learn what is a curve. What is a curve or what is a curve surveying? Imagine we have got two straight lines which is deviating from each other at some angle. That is, we have a straight line AV over here, and this AV is getting deflected by another straight line which is BV. Now, in order to change the direction, here in the sketch what we are observing is AV is one of the straight stretch and BV is another straight stretch. There is a change in the direction of the normal straight stretch. That is, AV will be the first line and BV will be the second line. We are supposed to set out a smooth movement between this AV line and BV line. In order to do that, we provide it with the help of a curve in this form. That is T1 and T2. This is all about curve surveying. Now, curves are basically classified into horizontal curves and vertical curves. Horizontal curve is nothing but wherever the curves are set out on horizontal plane, and vertical curves are those curves which are set out in vertical plane. Horizontal curves are further subdivided into simple circular curve, compound curve, reverse curve, and transition curves, whereas vertical curves are divided into valley curve and summit curve. Coming to what are these curves, let us see what are the how each different curves looks like in horizontal curve. This is a simple curve. Simple circular curve is nothing but you have two parallel straights and you are supposed to set a curve between these two with just one radius. This R represents single radius, T1, T2 represents the simple curve. So this is our simple circular curve. Coming to compound curve, we have three lines over here, T1V, VT2, and there is one more line over here. We are supposed to set out curve between these three lines. So we have got R1 as one of the radius and R2 as another radius. So any curve which has got two or more number of radius in it, we call that as compound curve. Coming to third one, which is called as transition curve. Transition curve is nothing but whenever there is a straight stretch and a curved stretch. It is very difficult to move from a straight stretch suddenly to a curved stretch, because when we are moving in this manner, there is a possibility that the outer wheel will be raised outwards and skidding possibility is more. In order to avoid this possibility, we provide a curve which has infinite radius to finite radius or finite radius to infinite radius. This curve is called as transition curve. Now, one more curve is called as reverse curve. Here it is very clear that there is one straight line, another straight line, which is in opposite direction. That is, we need to provide a smooth transition between these two straights in the form of a reverse curve. Reverse curve is also called as S curve or serpentine curve because of its shape. Now coming to vertical curves. In vertical curves, we have got two major categories. One is called as a summit curve and another one is called as valley curve. I hope the figure is clearly depicting what is a vertical curve. Curve provided along a vertical plane, and since this indicates a summit, this is called as summit curve, and here it is the transition is between the lower edge, hence it is called as valley curve. Going to next concept, which is called as elements of simple circular curve. Each curve will be defined as either right hand curve or left hand curve. That is, if the curve is being turned towards your right hand, the curve will be called as right hand curve, and the deviation is towards left hand, it will be called as left hand curve. Coming to back tangent and forward tangent. Back tangent is any tangent which is before the start of the curve. That is, here you can see a line A, V, V dash. This line A, V, V dash will be called as back tangent. That is the tangent which is observed before the occurrence of a curve. Coming to forward tangent, BV will be called as forward tangent. Forward tangent is the tangent which occurs after the occurrence of curve. This is the curve, and T1, T2, we have something called as point of curve and point of tangency. Point of curve is the point from where the straight stretch stops and the curve starts aligning. And next we have got T2, which is called as point of tangent. This is the point where the curve stretch ends and the straight stretch starts. V is called as point of intersection, that is AV and VB, or back tangent and forward tangent intersects at a point called as V. Now other elements are intersection angle and deflection angle. At the point of intersection, we have two different angles. One is delta and another is theta. T1 V T2, angle T1 V T2 will be called as intersection angle, and V dash V T2 will be called as deflection angle delta. Whatever deflection angle we get over here will be the same at the center of the circle, which is central angle, that is T1 O T2. Apex or summit of the curve. Apex or summit of the curve is the point, peak point of our curve. That is, here in this sketch, it is the point C. Mid-ordinate is the distance between the long chord and the apex of the apex or summit of the curve. That is, CD distance is called as the mid-ordinate distance. Long chord is T1, T2. When we join point of curve and point of tangent together, we get the long chord. Length of the curve. Length of the curve is nothing but T1, C, T2. Tangent distance. Tangent distance is the distance between point of curve to point of intersection, or point of intersection to the point of tangent. Generally, T1V will be equal to VT2 for a simple circular curve. External distance is the distance between apex of the curve to the point of intersection, that is VC. Going ahead, we have something called as designation of a curve. What is meant by designation of a curve is, we generally define a curve by its radius. But in certain cases, when the radius involved is very large, imagining the curve on the ground becomes very difficult. In order to ascertain this, we define the curve in terms of the angle subtended at the center of the curve, or the arc length or the chord length that is subtended. This concept is called as designation of a curve. We define it either in terms of 30 feet arc or 30 feet chord. Here we have got a section where PQ is the points, O is the center point, PO is the radius, capital D is the angle subtended at the center of the circle, which has got 30 feet as its arc length. The distance 30 feet arc is nothing but radius multiplied by the angle subtended, converted into pi divided by 180 to convert it into radians. So 30 feet will be equal to R into D into pi divided by 180 degree. In order to define the radius will be equal to 30 into 180 divided by D into pi. Since apart from the angle subtended D, I have all other quantities, on substitution, it gets reduced to 1718.9 divided by D. It can be approximated to 1719 divided by D. Similarly, for a 30 feet chord, here we have got a 30 feet chord. This should have been 15 feet. Half of the chord length is 30 feet. So half of it will be 15 and 15. And the point of intersection, this point is termed as P dash. Now consider the triangle OPP dash. That is this triangle. In this triangle, if I have to define sine of this angle, Sine of d by 2 will be equal to opposite by hypotenuse. Opposite is P dash, hypotenuse is OP. P dash distance is 15 feet divided by R. So R will be equal to 15 divided by sine of d by 2. Since d by 2 is very small, sine of d by 2 can be taken as directly d by 2. Hence the equation gets reduced to R is equal to 15 divided by d by 2. Converting it into radians, it becomes d by 2 into pi divided by 180. On substitution, the entire equation gets reduced to R is equal to 1719 divided by d. The same definition can be done for 20 feet chord and 20 feet arc also. The definition goes this way. Just replace 30 in this slide by 20 for this slide. So for a 20 feet arc, we will have radius to be equal to 1146 divided by d for both arc definition as well as chord definition. Hence, in general, radius is equal to S into 180 divided by d into pi, where S represents length of the chord or length of the arc. Hence, for both chord definition and arc definition, R will be equal to S into 180 divided by d into pi. Going ahead, let us see what are the various elements of a simple circular curve. Elements of a simple circle, we define 5 different elements for a simple circular curve. First one is called as length of a curve. Length of a curve indicated by small letter L, that is T1, C, T2. T1, C, T2, L will be equal to radius multiplied by angle subtended between these two lines at the center, that is delta. Since it needs to be converted into radians, R into delta into pi divided by 180 degree, where delta is in degrees. This is the equation to find out length of a curve. Coming to next component, it is called as tangent length, that is capital T. Capital T is nothing but V T1 or V T2. Consider the triangle T1, V and O. In this triangle T1, V and O, we know this distance, that is radius. We do not know this distance T1V, or we are about to find out this distance T1V, and we know the angle subtended at the center. Since angle is here, this distance T1O becomes adjacent and T1V becomes opposite. Hence, we can use tan theta formula for this triangle. Tan theta or tan of delta by 2 will be equal to opposite by T1V divided by T1O. The component which I need to know is T1V. Hence, T1V will be equal to R into tan of delta by 2. Coming to next component, it is long chord. Long chord is nothing but the distance T1, T2, T1 or T1D, T2. In order to find out the distance T1D, T2, T1D, T2 is nothing but T1D plus DT2. Since this is the midpoint of the line T1, T2, we can also call it as 2 times of T1D. Now consider the triangle OT1D. In the triangle OT1D, using sine theta formula, sine of delta by 2 will be equal to opposite by hypotenuse. Opposite is nothing but T1D. Hypotenuse is R. Hence, the equation becomes T1D to be equal to R into sine of delta by 2. That is, capital L is equal to R into sine of delta by 2. Coming to the next 2 components, it is called as apex distance and mid-ordinate distance. Apex distance is the distance VC, that is from the point C to V. That can be written as total distance VO minus of CO. CO is nothing but the radius of the curve. The distance VC or VO can be found out using VT1O triangle using secant theta formula. We get the equation to be equal to R into secant delta by 2 minus R. R can be taken outside and the equation gets reduced to R into secant delta by 2 minus 1. Similarly, mid-ordinate distance can be R minus of R into cos of delta by 2. Taking out R as common, the equation gets reduced to R into 1 minus cos of delta by 2. Thank you. We will continue with the problems in our next class.